So we'll be looking at the product rule, and it's very important to note that when you are differentiating a constant, okay, when you are differentiating a constant, before we look at product rule, when you are differentiating a constant, it's important to know that constants are numbers. 5, 6, 1 million, okay, let's say 5/20, 2/5, fractions, anything, even minus value, -7, if you're differentiating any constant at all, the answer is 0. No matter how large that constant is, it is 0. Now let's delve into the product rule. Now please take down. Now the product rule of differentiation, is used to find the derivatives, of functions, which multiplies themselves. To find the derivatives of functions which multiplies themselves. Full stop. Okay? Now, given that y is equal to uv, like in this form, this is the form of functions, u times v. This means u times v. This function 1, this function 2. When you have two functions multiplying themselves, that is where you apply what rule? Product rule. Thank you. That's where you apply product rule. So it is sacrosanct to understand that you should have only what? Two functions. The first one must be your, the second one must be your v. First one u, second one v. Now to find the y over the x here, the product rule is giving us u dv over dx plus v du over dx. This is the formula for product rule. U dv over dx plus v du over dx. Now, u is the first function, v is the second function. dv over dx means differentiate v with respect to x. du over dx means differentiate u with respect to x. It's just like cross multiplication. U times the differential form of v plus v times the differential form of u. That's the idea. Alright, that's the idea. So now let's look at the basic example. So but please don't forget, it's very simple. The y over dx is equals to u dv over dx plus v du over dx. Don't forget that. So now look at these guys. So if we have, let's say, for example, if we have y equals to 2x times x plus 3. These are two different functions multiplying themselves. Given that y equals to 2x times x plus 3, now find dy over dx. Now in simple algebra, for instance, algebraic expansion, when you see something like this, you just do 2x times x, 2x squared, 2x times 3, 6x. What is your answer? X squared plus 6x, and that's your answer, right? But you will not do like that here. You will not just jump into expansion. You have to first of all arrange them. Your first function is what? Your second function is what? V. So you do like this. You say u equal to 2x, v equal to x plus 3. In the formula, you have dv over dx and du over dx. So you find your du over dx and you find your dv over dx. It will be important to arrange them like this. Place your du over dx under u. Place your dv over dx under v. So du over dx means 2x. Differentiating 2x is 2. How? Because differentiating x is equals to 1. So it's like you say 2 times 1 equals to what? 2. Remember, I said something about differentiating constants to be equal to 0. That doesn't mean that you say differentiating 2 is 0 and x is equals to 1. So 0 times 1 is 0. Wrong. Why? Because 2 and x are together. It's not 2 plus x, it is 2x. 2 plus x is even 1. Because 2 is 0, x is 1. But 2x is equal to what? 2. So whenever you see a coefficient with x that doesn't have a power, throw away the x. Collect only the coefficients. No matter what the coefficient is, even if you have 1000x or 1000 y, although this one is a different case altogether. When we look at this differentiation, I will tell you how to differentiate with respect to y. But 1000x is just 1000. Remove this x because it doesn't have the power. If x has the power of 2, you know our power rule now. 2 times 1000 will be what? 2000 x. But when x doesn't have the power, just remove the coefficients. Just remove x rather than write the coefficients. Do you understand? Is it clear? Just remove x, write only the coefficients. Now let us go here. Differentiating x is what? 1. When differentiating x, what do we get? 1. Differentiating 3 is what? 0, because 3 is a constant of. As it is now, you'll be able to get all you want to differentiate this function accurately. There's no other rule we can use in differentiating this function apart from product rule, because these functions are multiplying themselves. So there's no other rule. So 2x, x plus 3, 2, 1. So you have been able to arrange them accordingly and you have gotten what you want to get. So what do you do here? You just apply the formula, alright? Apply the formula that you have. Dy over dx is equal to, your u is 2x, dv over dx is 1 times 1. U is 2x, dv over dx is 1, just like you cross multiplying. This times this plus this times this. 2x times 1 plus what is b? X plus 3 plus, just bracket these guys, x plus 3 dv over dx is what? 2. Then you multiply. So at this point now you expand. 2x times 1 is 2x plus, work on these guys, x times 2, 2x, 3 times 2, 6, 2x plus 2x, like terms, 4x plus, this is your final answer, 4x plus 6. This is your dy over dx. So you must understand the different components of your product rule. Get them, implode them into the formula by substitution. So, here a final answer. Does that make sense? Yes. Alright. So, that is that. So, I want you to try this. If you have, let's say, y equals to 4x squared plus 6x minus 3 times 2x minus 18. So try this. So find dy over dx. Find dy over dx for this. Alright? Find dy over dx.